1995, 14 wolves are brought from Alberta, Canada, to be reintroduced into Yellowstone National Park. And here we see the Secretary of the Interior carrying one of the pens. And they're placed in what was called an acclimation pen so that they could get used to, being in Yellowstone National Park and not Canada. And the scientists could keep an eye on them before they're released. And the reintroduction of the wolves occurred during the Clinton administration. And we see Clinton there in Yellowstone with his daughter. And he was a very strong supporter of this project. And this picture up in the corner of the Native Americans, that's very significant because think back to the early picture back in 1870 of the camp, and then all the European Americans come in, the market hunters come in all along the plains, not just Yellowstone, decimating bison, elk, and various herds, completely changing Native Americans' lives, devastating their lifestyle and such. And so it's very significant that they're a part of the reintroduction, offering prayers and blessings. And they have been very supportive of wolf reintroduction, not only in Yellowstone, but in Idaho and New Mexico, for instance. Okay. And here again is wolf number 10. And if you look, you see the black right there. The original wolves and subsequently, throughout the years, various wolves have been sedated, collared, and tagged with radio collars so scientists can keep track of their whereabouts and study their behavior, what the different packs and such. And in that 10-day period in 1995, 14 wolves were reintroduced to Yellowstone National Park. And descendants of wolf number 10 are there today. So this is a very typical scene of what you'll see today. Wolf watchers in Yellowstone. And some wolf watchers dedicate a substantial part of their lives to not just watching the wolves, but identifying alpha female, alpha male, this pack, that pack. And if you're driving in Yellowstone and you see people actively looking in binoculars or a monoscope, you want to stop because either it's a grizzly or it's a wolf that they're watching. And they'll sit for hours on end and never see a wolf. And when I was recently in Yellowstone, when we were there driving along, and this is exactly what we saw, we stopped, and they had seen a wolf early in the morning and not for hours. But then I had the honor and privilege of seeing the alpha female. This is in the Lamar Valley. This is in the Hayden Valley Pack. The alpha female come out from the trees and went to the stream, got a drink, and then some other wolves came out and they're playing with the bison bone. And it was just, it's beyond words, awe-inspiring. So this is a typical scene in Yellowstone these days, although not everybody supports the reintroduction of wolves.
Susan went through that history, and it's really very important to the work that I've been doing in Yellowstone. I started there in 1996 is when I first started working there. And I'm sure probably even within this room there's a wide variety of opinion over the wisdom or the foolishness of these changing policies. I think that one thing that's really important for you to know, not everyone realizes this, I suppose, but you sort of think of these national parks as they put they make this boundary, and then they nature takes its course, and that is a totally erroneous view. National parks, like the rest of this country, the rest of the world, is very actively managed by humans, and it has been throughout its history, as Susan pointed out. So, like I said, there's probably some difference of opinion as to the wisdom or the foolishness of wolf reintroduction or anything like that. But I actually think there is one thing we can probably all agree on in this room, and that is taking the driving privileges away from the local bears was probably a good idea. So let's see here if I can figure out this thing. So now I'm going to focus on the what's called the Northern Range of Yellowstone National Park, so not the whole park. The Northern Range is in the northern part of the park, and you can see it's this shaded area right here. It's basically the valleys of the Lamar River and the Yellowstone River and some of the tributaries. And it's significant because this is a big elk wintering area. So the elk of Yellowstone Park, you know, in the summertime, they're up in the high country and, you know, doing their thing up there. But then, you know, it snows a lot in the winter, and that drives them down into lower elevations. So they spend their winters down on the Northern Range. And like Susan had pointed out, see that line right there? When the park boundary was drawn, they were protecting the thermal features, and so basically the last major thermal feature to the north is Mammoth Hot Springs. So they made the park boundary just a little bit north of that. And so you can see about half of it is actually in the Gallatin National Forest. So it's a split jurisdiction between the Park Service and the Forest Service, and that's quite significant in the story here. And here's a picture, typical picture on the Northern Range. It's sage-dominated rangelands, a lot of that's mostly Douglas fir back in there, and there's patches of aspen. So I first became interested in the 90s. And I was looking around for a PhD dissertation topic, and I happened upon a research paper by a guy by the name of William Rami, and he was studying aspen on the Northern Range, and wrote this paper, Aspen, Elk, and Fire in Northern Yellowstone National Park. If you recall, if you know the history of the park, 1988 was a big fire season out there. Much of the park burned. And so an aspen had been known to be one species that had been doing very poorly for decades on the Northern Range. So he and some other researchers went in and looked at it. And you know, they didn't really come to any great conclusion. They looked at fire. You know, aspen's an early succession species, so if you burn aspen stands, you get a lot of root suckers that come up and it'll reproduce. Climate change, of course, is always in the mix these days. They looked at climate, and so what I did was I decided that I was going to go in, and what they didn't do, you know, I looked at that line, that split, and I said, well, you know, there's lots of research in the park that says aspen's doing very poorly. Well, how's aspen doing north of the park line? It's on the Northern Range. It's just split artificially by this jurisdictional line, right? So I started researching that, wrote my PhD dissertation on it, and I did a variety of things. Here's an aspen stand in 1954, and you can see the loss of canopy. I quantified how much canopy had been lost over time. But the big thing that I did was I drilled increment cores, hundreds of increment cores, with a borer, and then, you know, you count the rings and you age the trees, right? So you're all familiar with tree rings and aging trees. And so here was the age distribution of aspen that I found within the park. So from about most of the existing trees, this would have been in about 1997 or so, 98, had been born, you know, came into the canopy in a period from about 1860 to about 1920. And after about 1930, nothing. There was not nothing, but relatively speaking, very, very little aspen was actually reaching the overstory after about 1920, right? And if you recall Susan's timeline that she went through, 1926 was when they took the last wolf out of Yellowstone National Park. So I went into the Gallatin Forest. Very different picture. Very, very different picture. And you can see from the graph here, you know, that most of the aspen that's in 1998 was in the Gallatin portion was in the post-1920 period. So very, very different situation inside and outside of the park. You know, the question is why? What's going on, you know? And so I had laid out all these transects in like 83 different aspen stands, another 80 or so in the Gallatin Forest. Spent, you know, a couple of summers measuring aspen and looking at climate records. They've got very good records going back to about the 1880s for climate there. Looking at fire history, you know, comparing stands that burned in 88 and ones that hadn't, and, you know, the whole fire history thing. And so these belt transects, it's a field sampling method that's used. Just imagine, you know, you're in an aspen stand in a 2 meter by 30 meter swath of land. You go through there and you measure various things. I'm going to talk mostly about the browsing because the really significant variable when you do the math is that on any given year, about 87% of the aspen ramets or the suckers got browsed off. So a little bit about aspen that you have to understand here. This is an aspen ramet is a technical term, or a sucker. And in the western United States, in Yellowstone, most of the aspen that you see are large clones. So they can cover acres, they can cover square miles. They can be very, very large, but they're all the trees are genetically identical individuals, right? There's an interconnected root system that is underneath the soil, and their reproduction is basically by sending up root suckers. And what's happening, or what was happening there, you can see this is an aspen, a heavily browsed ramet over multiple years. So what happens in the winter, elk happen to really like to browse aspen. They utilize it as a food source. And the way they grow is, you've got the leader stem, basically the top of the tree. And what the elk will do is they'll come in and they'll browse off the leader stem. The other older wood is a little bit too woody for them. And so what happens is this is the leader stem, and you'll have these lateral stems, or branches, if you will. And so what they'll do is they'll browse down off of that leader, and then the next year one of these lateral stems will take over as the leader, and it'll grow, and then the next winter they'll come in and browse down that lateral stem. So over a period of years, this is what you get, this kind of hedged effect of these small root suckers that never actually get up into the overstory, right? And they'll die after 8 or 10 years, and another one will come up. And of course, they're photosynthesizing, so once the overstory's gone, you get a lot of dieback because there's, they simply don't have enough food, right? And so that's very typical right there. And, so we concluded, that browsing, there was no statistical relationship, mathematical relationship with any climate variable we could come up with, or any fire history that we could come up with. It was really browsing that was suppressing aspen on the Northern Range. And the 1988 fires, which should have produced massive new numbers of ramets. But none of those actually reached the overstory, right? So I finished that research, and getting back to Aldo Leopold and this illustration that Colleen McCarty, a friend of mine who lives up in Sturgeon Bay, did to sort of illustrate the talk. You got the aspen and the elk and the wolf there, and then you've got some of those hidden animals in there. But Aldo Leopold was a man, professor at the University of Wisconsin, actually, man very much ahead of his time. And so many of you, I'm sure many people in this room, are familiar with his very famous essay, Thinking Like a Mountain, written in 1949. And so I highlighted the thing, he's talking about, just as a deer herd lives in fear of its wolves, so does a mountain live in fear of its deer. The range pulled down by too many deer may fail for replacement in many decades. And that's exactly what I was measuring on the Northern Range with the aspen. For 70 years, there was essentially had been no reproduction of overstory of aspen in Yellowstone. So, I was very fortunate, actually, because I finished my PhD dissertation right around the time they reintroduced the wolves. And when I did that work, I really wasn't looking at the wolf as a driver in the system to shape the character of these forests. But, obviously, wolves eat elk, right? So maybe something's going to change. And so I said to myself, this is a once-in-a-lifetime opportunity that I have right here. Somebody needs to study this and follow this, and it might as well be me. So what I did was I asked kind of 3 or 4 questions here. I figured the first question is, why or how is browsing different than it was historically? How have the aspen stands changed? And has wolf reintroduction help explain this phenomenon? So the first question is, I was measuring in the late 90s about 87% browsing in aspen stands on the Northern Range. Now, is that different from historical? You know, I mean, in nature, you know, there's always swings. You know, it's not a steady state. You know, things change, but you know, for 70 years there hadn't been any aspen reproduction, overstory replacement. And when you start to get worried as a range scientist, a forester, that sort of thing, is you've got this range of natural variation, but are you outside of that range? Have you changed the system so much that you're outside of this natural range of variation? And so I didn't know that. So what I said to myself was, I want to know what the browsing level was in 1920. I want to know how many aspens were browsed in 1850. So think about how you can actually get at that question. I mean, this is, you know, this is the fun part of science, you know. So what I did was, I was very lucky. There was a guy by the name of Edward Warren. In 1921, he worked near Roosevelt Lodge, Tower Falls area on the Northern Range. He was interested in the beaver, and he wrote about a 100-page report all about the life of the Yellowstone beaver. It's just a wonderful piece of science. He's another guy that was ahead of his time because he measured everything. And if you're going to study the beaver, well, what do beaver use for their food, for their lodges, for their dams? They use aspen, they use willow. So he made a lot of observations, measurements of aspen in the areas where the beaver were, and he measured a lot of diameters of trees. So if you have studied forestry, or if you've looked at trees, I guess you don't have to study forestry, you know, big trees are old, right? And little trees are young, for the most part. And so you can, using regression techniques, you can predict the age of a tree of a certain species if you know its diameter. And so, especially if it's just one species, which is aspen, and I could go to the exact sites that Warren worked in, and I could measure trees that were alive in 1998 and get all these range of DBHs, and then I could core them and get ages, and we developed an equation to predict the age on the diameter. Same sites, same species. Here's what we came up with. 1921 is when he did all of this. And I aged, using that regression equation, I aged back to about 1750. And you can see right there, and what we concluded from that is, yeah, aspen regeneration into the overstory has been pretty consistent. I mean, there's a couple of gaps in there, about 20 years or so. Nothing like 70 years. So what we took away from that, you know, one piece of evidence from, and then I had my own cores that brought it out to about 1930 or so. So there, from 1750 to 1930, there had been fairly continuous aspen regeneration on the Northern Range. Then something changed. Another piece of evidence. I like this. This is so cool. Here's a heavily browsed aspen sucker, and this is a split aspen log. And as it turns out, I was just astonished when I first learned this, and it astonishes me to this day. The pith of the tree, which is right here, this little thing right in the center, you know, it's nutrient transport in the tree, but what actually in the pith of the tree, it leaves what's called a pith trace. That's a browse event that happened maybe 100 years ago when this tree was, you know, a baby aspen tree, right? And so what we did, and I still can't believe we did it because we had plots all over the Northern Range, and if you've been there, it's a big place. For 2 years, we carried a chainsaw in our backpack all around the Northern Range to these aspen stands that we were sampling, and we sawed off these pith traces in meter segments on the first 2 meters of the tree, split them and quartered them, and counted browse events. And so we concluded from that the browsing levels when these trees were young, which was in the 1800s mostly, were very much less browsing, right? So there's quite a bit of evidence, right? So